All right, today in chapter 3, section 3, we're going to combine our knowledge from 3.2 to do what's called a system of inequalities. So we're going to have two or more inequalities that we're going to graph together. They're going to have solid and dotted lines like we did in 3.2, but they're both going to have shading. We're looking for our solution is going to be the area where the shading of the two lines overlaps. So I'm going to start out with my blue equation here. Our goal is always to get them in slope-intercept form. This one is already there. Notice we don't have a number out here. So our y-intercept is said to be 0. All right, I'm gonna put this over 1, and now we have our slope of 2 over 1, which we're used to being up 2 and right 1. So I'm gonna make that line up 2, right 1, up 2, right 1. We're gonna keep going both directions. And because there's no equal to sign in this graph, we are going to make this a solid line. We'll go all the way up. Now I'm not going to shade just yet because I got this orange equation, which I'm going to work on now. We have multiplication by -6 and a positive 4x. Like in most equations, we're going to get the y by itself. By subtracting 4x from each side, I'm left with a -6y is greater than -4x plus 18. At this point, I'm going to divide everything by -6. And when I do that, I have to remember that this inequality, if I divide everything by a negative, has to flip. Oh, I'm going to keep the bar underneath there that says equal to. My final answer now will be y equals -6 is canceled. Negatives will cancel over here, and 4 over 6 will reduce to 2/3. Positive 18 and -6 will simplify to -3. So in this case, oh, I screwed up on the blue equation, guys. There should be a dash line because there's no bar underneath there. So we'll do that. This one, however, is going to be solid because of the equal to. We'll start at -3, and we're going to go up 2, right 3. Once again, because we have the up here and the right. Up 2, right 3, and then we'll work backwards down to left 3, and so on. This one is going to be the solid one. So we're going like that. All right, now for the shading. When we have two lines intersecting, we're gonna have 4 areas. One of them will be will not be shaded at all. One will be shaded dark, and the other 2 will be light. We're looking for the area where the shading overlaps. That's where our solution is gonna lie. So I'm gonna start out with my blue equation here. I'm looking at this line. I'm gonna start at the intercept, and greater than tells me I'm gonna shade above the line. So I'm gonna shade really light here. That's where my blue is going. Okay, so I know right now my final solution will not be in these 2 areas. It will not be in here, it will not be in here. We're gonna look to see where the orange is gonna go. Our y, our orange one, is less than, so I go to the y-intercept, and I say, okay, go below the line. Less than is below, so I'm gonna go real light, it's in here. All right, so from the 4 areas, I have blue over here, I have orange here, nothing here, and then in this area, I have both blue and green. That's the area where our solution is, so I need to shade this area in really dark. This is our solution. So any point that lies in here or on this line, but not this line, would be a solution to both equations. And that's what we're trying to have happen. All right, I'm gonna give you the next 2 equations. I want you to see if you can do this one without my help. After you've done it, check your answers to see if it works. It'll be on the next video.